Hi everyone, welcome to a new video. In this video, we are going to talk about concurrency, Go concurrency. So we will start off by some theory. We'll learn what concurrency is, then what parallelism is, how these things are different, how Go has a very superior concurrency than any other language, and we'll also look how these Go routines work. I think it will be a multi-part series because there's a lot to cover. But we'll start with this thing. Then we can go on and practice a lot of questions on Go routines, then on weight group, uh, channels, mutexes, etc. There's a lot to cover. So let's get started. Firstly, what is concurrency? What is parallelism? How are they different? This is very important. So if you look at these diagrams, idea behind concurrency and parallelism is to run multiple processes at the same time. But how they do it is different. How it is done is different. If we look at concurrency, we can see three processes are being executed. Even in parallelism, three processes are being executed. The only difference is that with concurrency, we only have one core. With parallelism, we have multiple cores. So if you now look at this, you'll understand that concurrency is handling multiple tasks at the same time, but not necessarily executing them simultaneously. What I mean by this is that we have only one CPU or we have only one core, and doing, it is actually not executing all these three processes at the same time, but rather what it is doing is it is context switching between the execution of these three processes in such a way that it appears to be all three processes are running together. Why are we doing this? We are doing this so to save time so that we can efficiently use our resources, right? So let me write it down. With concurrency, what we are doing is the CPU slash core switches tasks. This is what happens with concurrency. So one core is there, and that one particular core is executing all the processes, and the CPU or the core is switching between all these tasks via context switching. Now, what is context switching? Context switching is nothing but it's a concept of operating system. If you have studied there, what happens is if one process is being executed, we can save the state of this process even if it is not completed. So this process we were executing, but it is not completed yet. We can save the state of this process and we can start executing another process. And after some time, when we come back to this process, we already have the state saved. So we'll context switch back to this one and we can start executing it from the place we left. That is what context switching is. And why would we do context switching? Why would we want concurrency? As I said, we would want it because we want to have we want to make use of our resources efficiently. For example, if this process was running and this process went for IO or this went to sleep, now we would not want our core to sit idle at that point in time, right? For example, this went for IO for 10 seconds. Now core is sitting idle waiting for it to like do all the IO and stuff for 10 seconds and then execute it. So that doesn't make sense, right? That's why we will use concurrency so that whenever this goes to IO or whenever this goes to sleep, whatever is happening, whenever we have time, we can context switch and we can start working on other processes. Now, this context switching or this execution of all these processes happens so fast that it gives us an illusion that all three of them are being simultaneously executed. But actually, they are not being simultaneously executed. They are only being executed at the same time, but by the help of context switching. Similarly, with parallelism, what happens is each task gets a separate code. Let me write it down. So with parallelism, it's very straightforward that every task is being executed, every process is running, and every process is running in different core. So this is actually being simultaneously executed, and it is being executed at the same time. So it's like if you look at this, we have a circle. It's like this is concurrency, which says that our processes should run at the same time. Inside this, there is a subset called parallelism. Parallelism, and this basically says that yes, the processes are being running at the same time, but actually they are running simultaneously also, and they have each core, like each process has a separate core where it is being executed. So that is what the difference between concurrency and parallelism is. To summarize whatever we have said, concurrency basically is that we are trying to handle multiple tasks, or we are running multiple processes at the same time, but we are not necessarily executing them simultaneously, because one core is actually running multiple processes. How? By context switching between those processes. Whereas in parallelism, what happens is, with parallelism, multiple tasks are running, are being executed at the same time by multiple cores. Why would we want to do concurrency? So that we can effectively use our CPU resources. Because if one process goes to IO, we would not want it to wait, right? That's why we have concurrency. So now we'll talk about how Go routines work. I think before that we should know what Go routines do, right? So Go routines basically can be you can create any function, you can convert any function to a Go routine by just adding a Go keyword at the beginning. Maybe we should first do an example. Let's create a file. Let me zoom in a bit. So let us do one thing. Let us create a function. Let me call it one, and let me simply do a print statement, and we will say from one, right? And then let us create another function called two, which we will create using Goroutine. And then we can say from two. Now what I want to do here is I can call one here this way, right? And I can call two this way. If I have to create a Go routine, what is a Go routine? Go routine is a way through which we can uh, perform tasks, or we can perform processes, or we can run these functions concurrently. So I just have to do go at the end, and it becomes a Go routine. So now this function call, this two, this two function that we are using will be running concurrently. What happens is here, first one will run, then this will run concurrently, but the function gets over. The main function gets over. So nothing will be printed for two. Let us try running this. And it says from one. Why does it say so? Uh, because this ran, and this gave us from one, and this became concurrent, but the main function executed, the main function process got over, but the main function execution got over. So this was never printed. So for that, let us do one thing. Let us add a sleep command here. So let us make it sleep for 10 seconds. And now let us run the same thing again. It still says from 1. Okay, that is because we added it here. Let me do one thing. Let me add it here. So that this is running concurrently. And by the time we reach 1 and it waits for 10 seconds, this will also be executed. So now you will see we have from 1 as well as from 2. So this is basically how Go routines work. If we add Go at the end of any function, it becomes a Go routine. Let us do another example, and we will use anonymous function in this one, and we will create Go routines for these anonymous functions. Let us create a separate project itself. So how we create anonymous function is we simply do not give it a name, and we will call it. Let us create a basic for loop. We will start from 1, we'll take it till 10, and simply print it. I. So what this will do is this will print all the numbers from 1 till 10. If we have to run this, first let's get into the anonymous func. So this simply runs all the numbers from 1 till 10. What if we create anonymous functions here? What I want to show you is that when we will run functions concurrently, then both of them will be executed at the same time. So you'll see the difference here. So we'll copy this same thing again. Now what happens? Before that, let's remove this go part and let's run it again. So what happens is first function runs and then till 10 and then the second function runs, right? What happens is first this function is running and then this function is running. So it will print 1 till 10 and this will again print 1 till 10, 1 till 10. Now what if we add a go routine here? So now this is a go routine. This is also a go routine. But as you can guess, if we run it right now, it will simply exit, right? Because the main function has nothing now. These will be executing concurrently, but the main function will be over. And our main execution is what matters. If main execution gets over, then these go routines will just be of no use. So let's do one thing. Let's give it a time dot sleep. Let's make it sleep for 4 seconds. And let's give a ending printing statement end. Now when we will run this, you will see that firstly it ran 1, 2, 3, 4, which is the first function, right? And then it came 4, 5, 6, 7. Okay, one ran 2 times. Now, if you look at all this stuff, you'll see that both of them are running concurrently. So 1, 2, 3, 4, and then one comes again. Then one comes again. Then it keeps on running, and then it starts from 5. Let us do one more thing. Let us add one here, and let us add 2 here. Also, let's do one thing. Let's give it some sleep. Uh, I think milliseconds would be good. I'll add the same thing here also. I think this should work fine. Let us increase this in case the execution ends. And now let us try to run. What I want to do here is I don't want to see all the results directly. I want to see the process, how these results are happening. So now if we run main.grow, we can see that how things are running, right? One and then one again, then two, two, one, one, two, one. This is how all the things are running. So we can clearly see how these are being executed simultaneously. First two runs, then one runs. This is also very good observation that it is not necessary that if we are running this one first, then this will be running first. Like even the first time, if we look at our result, the first one that runs is that of two. So with Go routines, both of them are being executed concurrently. So it's not necessary that it starts with the function that you wrote earlier. That's also very important. And then we can see all of them are running concurrently. So that is basically the idea with what happened here. And I'm not sure what happened. Let me run again. Also, one more important thing I would like to say is it is not necessary that this will give the same pattern every single time. Maybe that end thing was happening due to some other reason. What I'm saying is that this pattern will not come always. Every time there will be a different pattern because they are being executed concurrently, and every single time there will be some variables that would be changing. So not you'll not get the same results every single time. This may be the case if you are running loop for like we are running between 1 to 10. If we run a loop for 1 to 1000, then it will give a different result. So this is basically how concurrency works in Go. Now that we have done some practice and we have seen how Go routines are implemented, maybe we can now look at how Go routines work. So how do Go routines work? Firstly, why do we use Go routines? I hope you are now able to understand why we use Go routines. We use Go routines so that we can concurrently execute these functions. These functions can be can be run concurrently by the help of Go routines. So how do Go routines work? Now, the first step is creation. Whenever we add Go keyword behind any function, it becomes a Go routine. So a new Go routine is created. The Go runtime will create a new Go routine. Now what happens is, second step is that Go routine is given like it is allocated some memory in stack, which is about 2 KBs. And this is game changing, which is about 2 KBs. And this is game changing. That is why Go is like the best. Go has the best concurrency model because if we look at, for example, Java, I think for Java the threads take up to 1 MB at least. So that's one thing that Go does better than other languages. Next, what happens is we start executing the Go routine or we start scheduling the Go routine. So how this happens is there is this thing called M is to N scheduling. What do I mean by M is to N scheduling? M number of Go routines will be executed in N number of OS threads. I hope you know what threads are. Threads are basically in operating system. It's like a process can be divided into multiple threads. So threads are like this uh, sub processes, and they would share the same memory and resources. Like all the threads inside a process will share the same memory and the resources, but they will run independently. So threads are like lightweight sub processes. What I was saying was that m number of Go routines will be scheduled in n number of OS threads. How that works is there is this Go scheduler which is responsible for the working of Go routines. So the Go scheduler runs on a single OS thread, and it is responsible for like all the scheduling that happens for other Go routines. How this will work is we'll see in the next step. So context switching. How this works is with context switching, what happens is that the Go scheduler, it's the job of the Go scheduler that whenever there is like IO or sleep or whatever, any of like anything where we can make sure that the OS thread can start executing some other uh, Go routine, at that time it will context switch and it will start executing some other Go routine. In fact, it is also preempted. So there is also like preemption. What is preemption? Preemption basically means that if a Go routine is being executed or it is being run for a long time, then it will be preempted because it is taking too much time, right? Another Go routine will be executed on that OS thread, or another Go routine will run on that same thread. So this is how, by the help of preemption, we can make sure that it is being effective, right? Only one Go routine is not running on that particular thread. Next, I have written this work stealing. What I mean by this is that if there is a processor that has, for example, no Go routines to run, then it can steal work from other processor. Now, this will be done so that our systems remain busy or whatever, or we can say that our resources are nicely used. Resources are efficiently used. Yes, efficiently is the right word. And then like how it is completed. So how this is completed is that the Go scheduler is responsible for uh, triggering the garbage collection and synchronization. For example, if we are using channels, etc., then we'll talk about channels. So the Go scheduler that we talked about will be responsible for that. Otherwise, when all the work is done, then or when we are going back to the main execution, then the Go routine, the Go scheduler will trigger the garbage collector and the garbage collection, memory deallocation, etc. All those things would happen. So this is basically how Go routines work. If I have to show you visually some example, so if this is the uh, main function, then we can create Go routines, something like this. These Go routines will be running parallelly, concurrently, not parallelly, concurrently. So at this point, I created a Go routine by the help of Go keyword. It will start being executed concurrently with the main. But as soon as the main is over, this will also be over at that case. Do one more thing here. Let me add something called wait, which we will study later on. So I have added something called wait. With wait, what we do is we wait for the Go routine to be completed, something like that. We will study it later on. So now what happens is, let me remove this. Now what happens is we create a Go routine here. So a Go routine is created, then some memory is allocated, then the M is to N scheduling happens. So for example, we created multiple Go routines. So at this point, we created multiple Go routines, something like that. M is to N scheduling happens. So all of them are being running concurrently. Context switching would happen between the OS threads that we have scheduled all these Go routines on. Work stealing would happen. And at the point of completion, the Go scheduler will make sure that all of the memory is deallocated at this point. The garbage collector is running, all the memory is deallocated and stuff. And we can start from execution error. It will wait for this time before all the Go routines will run, and then we will come back to the main execution. I think we have covered a good number of things in this video already. Maybe we can talk about other things like channels, about, like we said, wait in the coming videos. So for now, let's keep it short only. Let's keep it till this point only. And in next videos, we will first talk about wait groups, then we'll talk about channels, then we will talk about mutexes, and all of these things. We'll also do a lot of practicals, a lot of programs in this. So for now, I hope you were able to understand what these Go routines are, what concurrency and parallelism is. I hope this video was helpful. You can also watch the coming videos to understand Go concurrency completely. If you also want to study Kubernetes, then I have a lot of videos on Kubernetes as well. But in either case, thank you for watching this one, and I'll see you in the next one.